Hello everyone, myself Shubham Goel. I am doing my Masters in Computer Science Engineering from Thapar University Patiala. Today I am going to discuss with you about my research work which I have done in my Masters. The title of my thesis is Toward Designing Fuzzy Set Based Intelligent Broadcasting Techniques in VANETs. VANETs are Vehicular Adhoc networks. Adhoc network. Adhoc network is a special kind of network which is formed by just a minimum requirement for this ad hoc network, and the network which is formed by this combination of small network elements is not permanent network, it's a temporary network. VANETs are special type of mobile ad hoc networks in which mobile phones are replaced by vehicles. There are two type of communications in VANET. One is V2V communication, that means vehicle to vehicle communication, and other one is V2R communication, that means vehicle to roadside communication. For providing roadside communication, there are RSU available on the roads which are fixed on the roads, and both of these communications are integral part of intelligent transportation systems. This is a simple scenario which I have shown for intelligent transportation system. Here I have shown a communication between vehicles which is showing V2V communication, and this red car is communicating with RSU which is showing a V2R communication, and here I have shown a radio station which is providing access to all RSUs for any information which a government going to be broadcast to all the vehicles or some centralized agency. Broadcast term problem. Broadcasting is a method of propagation of message from one node to all the other nodes in the network, which we all know. In the VANET, communication between the vehicles is mostly broadcast based, and if some vehicle is getting some information and this information is going to be broadcast in the whole network, for providing this we need a relay nodes which will rebroadcast the message which it receives from the sender to the other nodes in the network, so that the message can be reached to its desired target. But the problem arises due to this rebroadcast is every vehicle in the transmission range of the sender will rebroadcast the packet, and for further rebroadcast all vehicles in the transmission range of that relay will going to be again rebroadcast it in the network. Due to the number of redundant messages is increased very much, and due to this more number of redundant messages, collision rate increases very much, which will going to affect the efficiency of the network bandwidth, which leads to a problem of broadcast term problem. Here has some techniques which I have read in my literature survey to solve this broadcast term problem. First one is simple threading, which I have shown here. This is discussed previously that every vehicle will going to rebroadcast it to all the vehicles in its transmission range, and here these vehicles will further rebroadcast it to the other vehicles so that it can reach its desired target. Second one is probability based flooding. Here the relay node is selected on the basis of probability. The vehicles having the maximum probability will rebroadcast it in the network further. And second one is distance based broadcast. In distance based broadcast, vehicles which is at the maximum distance from the sender vehicle will be selected as a relay node for further rebroadcasting in the network. And fourth one is location based spreading, which is shown here. Here help of GPS is taken to track the location of the receiver, so that only in the direction where the receiver is, sender can send the packet. Last one is cluster based flooding. In cluster based broadcast, vehicles which are elected by the vehicles in the cluster as a cluster head can only rebroadcast in the network. The technique which I have developed to solve this broadcast term problem is fuzzy set based, and it's a iFuzzy controller which I have made, because the problem of broadcast term problem is slightly solved by other authors, but not so much efficiently, and the problem of uncertainty which is not taken care of by many authors have also taken care in my iFuzzy controller. For handling this iFuzzy controller, I have used mobility, that means the speed of the vehicles, traffic density, that number of vehicles on the road at a particular distance, and intervehicular distance, that means the distance between the two vehicles, as an input parameter to my iFuzzy controller. Steps for relay node selection in my iFuzzy controller is discussed. First one is fuzzification, the other one is mapping of if-then rules, and third one is defuzzification. Fuzzification is the process of converting crisp values to fuzzy values. Here I have shown the fuzzification of the distance metric, I have shown the fuzzification of the mobility metric, and have shown the fuzzification of the distance metric. The example we will discuss this. Like crisp value for distance density metric is 0.3. For the fuzzified value of this 0.3 is 0.4 under the sparse set and 0.2 under the medium one. So set having the maximum fuzzified value is taken, so that it is this 0.3 crisp value will come under the sparse area. Here if-then rules. I have made many if-then rules, some of which are discussed here. Like if the value of the distance is large and mobility is low, then density is dense. So together all these will make the fitness rank as perfect. That means this vehicle is perfect for selection as a relay node. If distance is large and mobility is very fast and density is medium, then fitness rank is not acceptable. That means this relay node cannot be not be taken as a relay node for further rebroadcasting in the network. Defuzzification is the process of converting the fuzzified values to the crisp values, because all algorithms for vehicles will work on the crisp logic. So, and all the rows here in every column is correspond to one if-then rule, and combined effect of all the rules are taken here, which is showing the defuzzified value of the node, which is 0.6. Simulation. The model which I have used for my controller is on the basis of simulation of urban mobility, that means SUMO. It's a simulation tool for generating a configuration, or for generating a road network. Will use this flowchart. Like for basic requirement of this is node file and edge file. Node file will contain the information of the junctions, and edge file will contain information of the connections between these junctions, both of which are combined with the help of a netconvert tool to generate a network file. And the network file is combined with the root file, which will provide description about the vehicles, like what the speed of the vehicle, acceleration, deceleration, color, is everything discussed in the root file. And all these are combined to give input to this SUMO file. We generate a SUMO configuration file. Here I have shown the traffic moment. This is the network file. This is a network of road which is generated by the simulation. Here these yellow and red are showing the vehicles. Now here the vehicles density has increased. Here I have shown some view where traffic density is further increased. And after getting the simulation model, the traffic model, we will generate a trace file for this vehicle model, which going to be input to my iFuzzy controller. And here are the results of that iFuzzy controller, in which these graphs are showing the effect of input parameters on the fitness rank. Like if we take a graph, first graph, mobility versus distance metric. Here if the distance is small and mobility is less, to round about from -1 to 0, then it will going to provide a fitness rank the highest. But if distance increases further, then fitness rank slightly decreases. Similarly, if mobility increases, then fitness rank also decreases. And similarly, all these mobility versus distance density metric and distance versus distance metric density metric is discussed. Here is the deliverable which that means the conclusion of my controller which I have made for selection of the minimum number of relay nodes for efficient and fast rebroadcast of a safety message. That means the safety message which is broadcasted by ambulance or some other police vehicle or some other emergency vehicle can be safely and efficiently broadcasted in the whole network in very less time and without any packet loss. The relevance in the real world for my this iFuzzy controller or my work is the possible practical implementation of this work can be ranged from efficient traffic management to a safe transportation, effective enforcement of traffic regulation, which is very important for an efficient traffic management, and timely availability of rescue and relief in case of a road mishaps. Like if some vehicle is met with an accident and that vehicle wants to transmit a message that to some patrolling vehicle that please come for my help if person is unable to call someone, and by this method a precious life can be saved. Here are some publication which I have done during my ME. This first one is first paper is accepted in Springer conference in Bangalore, and second one is an IEEE international conference. Here are some references which I have used for my literature survey. Thanks for having this for listening this video. Thank you. If having some problem or some queries, you can mail me on the email ID mentioned in the video. Thanks.